code is structured correctly, um, columns, tables, etc., etc. Next, after we do that, we are going to get into this week's objectives. So this week's objectives are logical operators and aggregate functions. Not only are we going to focus on aggregate functions, but we also are going to focus on categorizing our data based on those aggregate functions as well. So since everybody can see my screen, okay. So last week we focused on those DML languages, data manipulation language. We touched on select, insert, update, and delete. We talked about ensuring that when you write your code to retrieve data from the table, that you select, you put whatever columns you need, select this column, that column, this column from our table. This will always, whatever you want in your output, that is what you put in your select statement. We also talked about how ideally for best practice, it is not, oh, thought I clicked on it. But for best practice, it is not good to do select star. It's better to be explicit with the columns you want, like select this column, that column, this column from this table, because that allows, I mean, you pretty much, when you select star, you pull in all the data, all the tables, all the columns, and you really don't need all that. Insert. We talked about how you insert records into a table. You also have had the opportunity to do that with your coding challenge as well. Um, and the syntax for that is insert into the table name, the columns, and then the values. Everything has to align explicitly in order, like you have your customer ID here, first name, last name. Not only order, but data type. If I have to treat this like an integer or a string, for it to adequately insert. Update. Update is when you are updating records in a table. And essentially the data already exists, but you need to do an update. Update table name, set our column to this value, where. Where is a condition. I'm telling you to update this table, set this column to this, where this column equals John. Where's the condition? It also allows you to filter that data. Select this column, where this column equals this. Delete. Delete does exactly what it says it does. It removes that data from the table. Delete from this table name, where this column equals John, where this condition is met. Y'all remember, everything we do goes back to tables or columns. If whatever you're doing, if you're pulling data from a table. And you're also pulling columns from that table. So think just table or columns. If you're doing something in SQL, you're doing it to a table. And the appropriate way to structure it is to always structure it like you're treating it from a table. Select these columns from this table. Your conditions, where this column equals John, where this column equals it, goes directly under your from statement. So any questions regarding like the way that your data should be structured within the database or anything like that before we go into tonight's session? Which tonight's session is still gonna focus on that as well because you literally need that. But any questions? Okay. Let's go then. So first and foremost, let's get into one of our primary objectives for tonight, and it will serve as an introduction for you all because we haven't touched this before. Let's get into our logical operators. Okay. So, what are logical operators? Logical operators are essentially multiple conditions. So, let me see. Okay. So in this syntax, we talked about a condition where this column equals this. This is a condition or a filter. I'm gonna write it in a chat. Where is a condition or filter? Okay. So where is a condition or a filter? You can call it either way. And what it allows you to do, it allows you to explicitly hone in on the data that you're trying to pinpoint. If I tell you, hey, can you go to the store and get me some milk? That's all I tell you. That's the instructions. That's it. Go to the store and get me some milk. You have never gone to the store for me. You don't know me. You don't know what I want. You don't know what I drink. I tell you to go to the store and get me some milk. That's not specific enough. But if I tell you to go to the store and get me a half a gallon of unsweetened almond milk in this name brand, those are conditions. Go to the store, select milk, where half a gallon, where the gallon is half a gallon, and what I say, unsweetened, and flavor equals unsweetened, and type equals almond. Those are your conditions. So if I tell you to go to the store and give me half a gallon of unsweetened almond milk, that's totally different from me just telling you to go to the store and give me some milk. There's two different things. Those are conditions. And the way we apply those in our natural language, like how I just told y'all, we do it all the time. Now it's time to write your code to capture it. So in the event you are looking for, you get a use case and you're looking for a certain specific data set. I need all the people who graduated in this year and are from this state and had a B average. You're going to select this from this table where this column equals this and that column equals that. Those are conditions. That allows you as an analytic professional to be able to explicitly label what you're looking for. As you navigate this space, you will never hardly just select star or select your columns from a table because it's so much data. And if I just give you all the data in the table, it does not answer any business questions, and it does not allow you to. It really, it ain't worth nothing because it's like, okay, what am I gonna do with all these? So most of the time when you navigate the space, you're going to have to use conditions to explicitly label what you need. Just like how I just told you to go to the store and give me some milk. You don't know what to do with it. But if I tell you go to the store and give me this type of milk and that type of milk and that type of milk, you're gonna know what to do with it. Data is the same way. So when logical operators, my thing. Hold on, let me get out of here. Logical operator. Now what? Okay, there you go. Logical operators are essentially conditions, but there are multiple conditions. You're layering your conditions on top of the next. Do you remember last week how I told y'all how I look at my data, how I look at my data like literally like cooking or like layering something. Like when you write your code, it makes more sense, even to this day, and I've been doing this for 12 years. It makes more sense to break down what you're looking for in small digestible pieces. Okay, I need this. Okay, I need that. Okay, this works. Okay, let me pull this. Now let me do this. Now let me see what's in here. Like literally break it down into small pieces. So logical operators allow you to do that because its core definition, those logical operators essentially are used to combine multiple conditions. And it provides their results based on those conditions. Now, the logical operators that we are going to focus on, which I chose these because they are like the most common ones. Like I've had people ask me, what are all the logical operators? I don't know. I don't know. It's probably 100 of them. I don't know. But I have people ask me like, what are all the logical operators? I don't know, and it doesn't matter because the goal is not memorization. So I focused on these because these are your most pertinent ones, and these are the ones that are going to that are most realistic, basically. So the ones that we're going to focus on tonight is their and, or, not, between, and in. These are five commonly used logical operators. And like I was saying, those logical operators essentially allow you to filter down on multiple conditions. So let's start with the and first. And when you look at this syntax, what do you think the output of this syntax will be? This one right here, the first one.
Employees in the IT department that makes more than 50,000.
Yep. This output is going to pull all, like you said, all the data from this employees table where they're in the IT department, where department equals IT, and the salary equals 50,000. Now, with this and condition, the basis of that condition is both of those conditions must be met. So in this syntax, I'm saying select these columns from this table where this column equals IT and this column is greater than 50,000. So it has to meet this condition and that condition. It got to meet both of them. Or what do you think that this syntax is doing?
It's going to return employees that are in IT or in HR.
Mm-hmm. And or doesn't care. Or said, okay, give me this one or that one. So if it meets this condition, I'm gonna get employees that are in both this department or this department. So of course my pool, my data set is gonna be bigger because it's like, give me either or. Just like I go out to eat and they be like, do you want strawberry or grape? I be like, I don't care. Give me either one of them. What you got? It's the same type of concept. Give me this or that. This syntax here, what do you think that this syntax is doing?
Running employees that work everywhere but IT department.
Yep. We're going to select all from this table where not. This column equals IT. Another way you can do this is actually like this. I'm going to put it in the chat and equals. Okay. Another way you can do it is essentially like that as well. And it's like I'm telling it where department. And instead of equals, I put that symbol in there, equals, and then what is it? Exclamation point. And it is essentially function as a not. You basically saying where it's not equal on here. Between. What do you think that this syntax is doing?
Employee salaries between 40 70,000.
Mm-hmm. Between is ideal for data for ranges. So let's say you are looking for, like, this is a good example where this column is between either one of these ranges. Or another place that this is commonly used is with dates. Like if I say I want all the customers that enroll or bought purchase something in the month of December, I would say where, whatever my column name is, and I would list I would say where, column name, between, because you gotta have it between there. And I will put my ranges here. Now with something like dates, it's important that you actually look at your column, which goes back to the data investigation. Go and look at your column and make sure that you're explicitly capturing what your data says or what the values say. Because naturally, what I've seen is that I'll say, okay, give me all the students that are all the whatever, and I say in the year of 2024. And people naturally just want to type in where this column is 2024. And it's like, Go look at your data. Go look at your data. And if it's a range, make sure that you're capturing the actual values that's in your table. And I'm gonna actually give you all a use case on that as well to apply that and practice that. And what do you think that this logical operator is doing?
Employees that are in departments, IT, HR, and finance.
Yeah. Now this end function, or it's not a function, this end logical operator, it looks at the actual values. So let's say you're looking at your columns and you have multiple values that you're looking for in that particular column. N is ideal for that. And one way that I would use that very heavily in my day to day role is like in healthcare when they look for certain ICD-9 codes. And it's like, okay, give me this data where all of these codes are met. That's a good way to do it. You essentially are outlining like the values where these values are in this column. So these are logical operators. Now, in the event, like I told y'all last week, whenever you're building your code, how you get like I worked on store procedures or jobs with like 400 lines of code, 300 lines of code, whatever. You essentially are building on top of it. So let's say if I want where this column equals this and this column is greater than 50,000, and this column is greater than, like I'm literally layering down where and or between, like I'm literally layering it like just on top of one another. And that way it allows you to test your code. So if I'm looking for something particular and I say, okay, well, this pulls what I need, but now I need this. You go through line by line and like capture what you need, execute it, test it. Okay, this doesn't look right. Let me see what I'm looking for. Add another line of code, execute it, remove that line of code, or whatever you have to do. Go back and forth, back and forth, back and forth, and that's how you essentially build like the rhythm of writing your data, right? Pulling your data. Do we have any questions about this? Okay. Uh, was everybody able to connect to the VM? Or does everybody have their was able to connect and see their view like this? And give me the thumbs up when you're ready to go. Okay. Okay, Melissa, I see you. Don't play with you. You say you're not gonna get caught slipping this week. All right. All right. So this is our database. We are connected. We ready to go. Um, this is our server. Our server, our server is the brain. It's the brain. It's the bread. It's the butter. It makes sure we good to go. If your server down, it's nothing works. So this is the brain. So when you get your role, it is not uncommon for you to have multiple servers. You'll have a production server. You'll have a dev server. You'll have all these different servers or environments, really, is what they're called. You have all these different environments that support different things. Production is live data. That's the data that is used in on the website. It's the data that HR is using. It's the data that the healthcare doctors are using. It's real live data. Dev is where you might do all your testing and things like that before your changes quote unquote go live or into production. So it's not uncommon where you will have multiple servers in your environment. Then we got our databases. So these boxes are our databases. These are our databases. And remember how we talked about a database essentially stores data. So let's go into last week we were in our data analytics simplified database. Let's go into our customer order database for this week's analysis. So you know how I told you last week, I was like, I'll tell you the database, but I'm not gonna tell you the table. Cause like I want y'all to be able to do like the data investigation type thing. So this is our customer order database. This is our database. Here, let me expand this thing. Okay. Here we have our tables. Everything goes back to tables and columns, period. These are our tables. Now, last week we talked about data investigation, data dependencies, data relationships. So let's talk about that again. These are our tables. Now, when I'm doing my data investigation, or what it literally sounds like, I'm going to investigate this data, I'm going to look at this data. You can do one of two things. You can expand your tables, look at your columns, and this gives you visibility to the actual columns that are in that table. This allows you to see, what's all in these tables. Go and look at your columns. Not only does this give you visibility to what is the data that's actually in that table, but it also gives you visibility to your actual data relationships. Your data relationships are essentially how your data is related. In your real life, if something is related, they have a common ancestor or a common relative. Data is the same way. So when you go in and look at your data and you want to look at your columns, you can say, okay, well, I see that these tables are related. So make it a good practice. Make it good practice to, first of all, data investigation and being privy to how your data is related. When you start doing your technical assessments, one way that they do it, it might be like live coding. And the reason that I teach y'all like this is because that's how a lot of technical assessments are. So when you're in those technical assessments, ideally the goal is for you to write the code, yeah, of course, but for you to be able to adequately talk through what you're doing. What that means is I give you this pseudo table, or I give you a few lines of data. I give you this table and that table and this table, and I say, hey, how many this? Hey, how many that? What is this? What is that? That's the technical assessment. You doing your assessment, you'll go through and you say, okay, literally say it out loud. Okay, I'm doing my data investigation. I see that this table, my customer table, is related to my orders table on the customer ID. So now I'm going through here and seeing which columns are in here. Like literally talk through it. Because the goal is for them to like understand, okay, well, he or she knows what she's doing. So just talk through it. And that's why I do it with y'all as well with the data investigation, because data mapping and data dictionaries and stuff are almost non-existent in analytics. What that means is I'm trying to be politically correct, but what that means is you're basically going to have to figure out relationships and stuff on your own most of the time. So I try to teach y'all how to have like that core skill because it'll help you. But anyway, so that's one way to do it. Expand your tables, expand your columns. Another way to do it is just straight up right click and select your top 1,000 rows. So here we have and this gives you actual visibility to, what the values actually are. Here we have select top 1,000. It's called a limit. It's going to limit basically 1,000 rows. If I put top 100, it ain't going to pull nothing but 100 rows or whatever I put in there. 100 rows, or whatever I put in there. So select my top 1,000 rows. Notice it has all of my columns here. Notice it has these commas in the front. That is best practice. Keep your stuff just like that. And the reason being, let's say I don't want the country anymore. I can just comment it out and I don't have to worry about anything else and just re-execute. Just keep all your stuff real clean, laid out, organized when you write your code. Any questions before we get into our use case, our first use case for tonight? Okay, let's go then. Let's go then. So, okay. So, I'm going to type it in the chat and I'm going to say it out loud. Okay. So, the first use case is to provide me an output of all the customers who are from the state of Colorado and who joined in the year of 2022. So the first thing, I'm gonna move this out the way so y'all can see that. Okay, so the first things first is data investigation. Go and look at your tables and figure out, okay, which tables houses this data? Which table supports me in answering this question? So first things first, data investigation. After you find the table, I'm gonna write it in the chat. Okay. First things first, data investigation. Which tables houses data? Second thing, okay, I got my table. Now which columns do I need to filter on to answer this question? Third question, ask yourself, okay, how is this data within those columns? Does my code match the columns that I created? What table did y'all use?
Customer ID.
Yep.
Customer ID. Yeah.
Yeah, the customers. Yep. What I say? Oh,
What table did y'all use?
why I got an echo? Okay. What else? Mm, what columns did y'all use to apply your filters? So I know we got our customer table.
We're gonna use join date and states.
Yep. That is correct. Any questions?
Yeah, hold on. I'm gonna see if this works.
Okay.
Cause I got Colorado,
Okay.
but I think I have too many statements after my where to get the year of the dates between.
The values. Can you share your screen?
No, I keep Oh wait,
Or you
let me
know
try to
what?
log in. Hold on, let me.
Yeah, I was gonna say, or you know what? Post your code in the chat and we can walk through it like that.
Okay. Oh, hold on. Yeah, I know I wasn't gonna like it. I had too many. I'm gonna try to join the session on my desktop,
Okay.
and then I can share.
Okay. Latasha, Candace, were y'all good?
Else order.
Which is, oh, you say kind of, sort of. You want to talk through it?
Um, I forgot how you not include line. Is it a dash in front of it?
Yeah, two dashes
Oh, two dashes. That's
like
what.
that.
Okay. Okay.
Candace, were you okay with it?
I'm sorry, I got a call.
Oh, okay. Bye.
No, 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 no. I'm gonna stay on a little bit longer. It is thundering and stuff.
I know. I'm sorry.
Okay, I can't do it on my desktop. I don't have a microphone or a camera on my desktop.
Okay.
But whoever just answered, I should probably be. So, okay, I'll tell you what I was trying to do. I successfully did Colorado.
Okay. That's one. That's one. Okay.
That's one. So, should we comment that out?
Uh-uh.
Okay.
You say where state equals CO, like how you got,
Okay.
and then come down on the next line and say and then the next, the comma,
But
not the
but
comma.
I felt like I said because I have and the join date
Yeah.
between
Yeah. Keep going.
between 2022-01-01
Yep.
and okay and 2022-12-31. Oh,
Correct.
you know what? Oh, hmm.
That's correct. That's correct.
Okay. Well, wait. Hold on. You know what I did?
I think I know what you
I
did too. Did you put your
I did not.
okay.
My semicolon.
Not the not the semicolon, the single quotes around your dates.
I did not.
That's the problem because the dates
I put I put it around Colorado this time.
very good. Go around Colorado. The only thing that you would, now I'm not gonna lie, dates and integers throw me for a loop sometimes. The
Okay.
only thing that you would not put your single quotes around is integers.
Okay.
So if it's just like straight up one, two, or three, leave it alone. But a date needs those single quotes as well. The same, you treat that date the same way you treat Colorado. It's a string.
Okay.
But that's 100% correct. That is the perfect example of a logical operator. Select these columns from this table where this column equals Colorado and join date between 2022-01-01 and 2022-12-31. 100% correct.
Okay.
100%.
I still got something wrong. It
What?
says, you know what else? This is another question.
What?
Okay, let's see. Um, so join date is supposed to be in brackets.
It doesn't have to be, but I keep all my stuff consistent.
Okay.
Like if it's starting to sound balanced, the recording my name. Yep. Email me, Candace, so it can be at the top of my email.
Okay.
And be safe.
Yeah,
But
I will. Thank. Like I'm worried about it's hail they talking about coming, but I also don't want to,
yeah, go on. Email me so it can be at the top of my so I can do it for you because I ain't gonna remember when I get off tonight.
Okay. Will do. Thank you.
Be safe.
All righty. Thank you.
All right.
Bye bye.
Bye. So
So, where I was going to comment out my where statement, just make a new line and
yeah.
say and.
Yeah, because that
Then,
is it is core. This is your logic operator. I'm joining multiple conditions. I got these columns from this table where this condition is met, where this column equals this, and this column between these two values.
all right, we rolling.
Let's go then.
All right.
Latasha, how you doing? I saw you squinting when I pulled that screen up there too.
My eyes so blurry. I guess from being on that computer all day and then doing this, my eyes blur. When I typed out the whole word Colorado.
I knew it. I knew it. That always gets people that and the date. It's like they want to put like 2022, but what you do like just go through and be like, oh, okay, this is how it is in the database. Now, if I was to say, Denisha and Melissa, y'all good? If I was to say where this column equals this or my join date, so change your and to or, and notice how your data set increases. Also, okay, good. Notice how your data set increases because I'm saying where this condition is met or this condition is met. So I'm saying either or. Give me either or. Give me grape or strawberry jelly. I don't care. So naturally, it's gonna widen your net with the data that it returns back. Cause like it's bringing. You see how you got some of these where the state is Colorado, it's different states over here, different join dates over here. I'm saying where it meets this condition or that condition.
Okay. Yeah, I had to pay attention to the
Oh,
same
the
time.
new
Let's look at that first.
what? Oh, the data invest. Girl, when I tell you
I just went straight to what you said and then pay attention to how it was on the table. You know
what
what I'm saying?
when I tell you that data investigation, especially as you get your role, when you get your role, that data investigation gonna save you a lot of heartache. I had a who was she? She was a QA analyst, a QA tester. So she tested software, and she actually just got a data engineer role. After she did this. So she was a QA tester, software tester, and then she got her data engineer role. But she was saying that she even at that point was still struggling with like going through and actually looking at that data. And I said, girl, it's one of those things to where it's like you gotta make it a habit and you have to like already be over there to like tell people go and look at your data because the data is a mess. Like it's literally a mess. Nobody gonna like ain't no data mappings. It's none of it. Like it's like, okay, let me go and look at my data. Denisha said, I am now after you explained the spelling out of the state and date. Yup. So going forward, just look at your values. Look at your values. How is the data actually in it? First things first, data investigation. Which tables? Secondly, which columns? Thirdly, how is the data over there? Like how is it even in there? So yeah. So any questions regarding logical operators? This is a very good example of a logical operator where this column equals this or and whatever this column between this and that you're essentially stacking. So if I want to come down here and I want to say and country whatever, like I just list another one and country, and you list your code, you just keep going. I think United States the only thing over here, so it don't matter. Yeah. So if I had multiple countries over here, whatever your conditions are, you just go on and list them out, list your code out. And that's how it gets that's how you get your data right there. So these were your logical operators. And or not, which is negates that condition, between and in. Any questions about these before we get into aggregate functions? Okay. All right. So aggregate functions. So aggregate functions fall into that's when you start getting into the like analysis, like at the core analysis. Like aggregate functions are essentially calculations. And let me pull my chat down. Okay. So aggregate functions are essentially calculations. So what are aggregate functions? At their core, they are literally calculations and they return a single value. The five aggregate functions are sum, average, count, max, and min. So there are actually multiple functions within SQL. We're actually going to do aggregate functions, window functions. We'll do window functions like later on because I don't really like them. I hate them, but whatever. We're gonna do aggregate functions, window functions. I think that's it. So functions are essentially anything that changes the way the data is structured in your output. So sum, average, count, min, and max. This is it. This is it. These are your aggregate functions. Now, of course, they get more complex. So tonight, what I'm going to do is I'm going to introduce you all to the baseline of aggregate functions, but I'm also going to show you how to apply your aggregate functions and then categorize your data. Because in this structure here, it's only going to return one record. But tonight I'm going to show you how to do this, and then I'm going to show you how to perform your aggregate function and then categorize your data in your data set, in your output to perform your analysis. So the format of our aggregate function, select. I told y'all, select is going, that's it, 99.99999. And you're going to be selecting. Select. Sum. This is our aggregate function. It's pink. Sum. Whatever column we are performing our aggregate function on goes in our parentheses. Select, sum, column name. Everything goes back to tables or columns. Column name from our table. So what do you think that this syntax is doing?
Adding.
Yep, yep. Now, don't get sum and count confused because the reason that I stated, naturally, if I say, okay, well, I want the sum of this column, for some reason, myself included, it's like, okay, I'm expecting like a count of something. But when I say sum, it's literally calculating the total of that column. So select sum, this is our column, from this table. Average. Average calculates the average of whatever column from your table. This is our function. This is our aggregate function. This is our column. Everything goes back to tables and columns. Period. You can't do nothing in here. Like you literally can't do nothing in here if you're not listing out a table or a column. Always remember that. Select. This is your function. This is our column from this table. Count. Count returns the number of rows or records in the table. So select count star. We put our star in parentheses or whatever column you're trying to get a count of. So if I'm trying to get a count of, you know, a certain column in here, count. But whatever column you put in parentheses. Max. Select max. Whatever column I need the max from in parentheses. This brings the max of whatever is in that column from this table. Min, bring the minimum value out of this column from this table. Now, if I was to say, give me, let's use count for example. Give me a count of from this table where this condition is met. I can do that all day long. Just like how we did in our customer table. We got select, let's say let's like this. Get rid of your columns, and let's say I want a count of all the customers that meet this condition that are from Colorado and they join between this date. So let's get rid of all our columns and let's do a count. Count, this our function, and then we put our star in parentheses. It's gonna give us a count, just like that.
So that counted your number of rows, period, not with your conditions.
It counted my conditions too, because my conditions are still included. If I was to get rid of my conditions, I only want to count from the table. I just can get rid of them like that. And I'm saying select, count from this table, execute. And I got over 1,000 records.
Okay, so it doesn't matter where in your script that count is, it's gonna count what the
It's gonna count the record, but it has to go after your select. It has to be
okay.
like this. Select like this.
So it has to be after the select before the where.
Before the from. Select, count from. Yep.
Okay.
And naturally before the where too, because that where gonna come after your from. But yep,
okay.
yep.
Okay.
This gives us the count of how many records are in that table. Now, y'all notice that this it produced this record right here. It basically gave us one statistic and it consolidated everything into that one little record. But it didn't even give it a column name. It ain't even giving no column name. So it's up to us to identify what our column name is. So here we have select count star from this table. This is what the output is. No column name. Now, what we have to do is we have to label what we're calculating. How do we do that? We do it with an alias. It's no different than you go to the DMV. This is my first name. This is my last name. This is my alias. This is a first name, last name, but call her or him this. Alias and code is the same way. This is the column name, but we're gonna call it this. And the way we outline an alias is as, and you put whatever your count. Let's say we count Colorado customers or something. And see how I name my column. Whatever I want to name, I can name this column A, B, C, D. It don't matter. You name it, whatever you want to name it to capture whatever you calculate. That is an alias, and that's going to come into play. That's going to also support you in our next session when we get in a join. But this is an alias. There you go. So let's say I wanted to um let's say I wanted to get the average total amount from my orders table. Give that's okay. Provide me the average total amount from the orders table. So I'm telling you the table, it is in the orders table. And with your aggregate function set up like this, all we want is one record. So we can only have in our select statement our aggregate function. What I say, the average total amount. We can only have one column, like one record in our one column in our select statement. So we're not going to have any of those additional columns. I'm going to show you how to incorporate those later. Right now, I just need the average total amount from my orders table.